Hey guys, it's Miss Aguilar again, and I'm just going to finish up with the last couple of problems that I chose from our projectile motion worksheet 3. And it's to finish this chart, the one that had it gave you the first set of information. It gave you time and delta x and delta y, and then velocity in the x. And then you just had to go forward and fill everything in. But what you have to do first is you first have to figure out how long or the time it's going to take, because the time's not going to end on a whole number. And I'm going to show you guys how to do that. So an object is projected horizontally off of a cliff that is 705.6 meters high with an initial horizontal velocity of 15 meters per second. How long does it take the object to hit the ground? So that first problem is going to be to solve for time. Complete the data table with the position of the object in the x and the y direction and the y velocity for each second of travel. Use g is equal to negative 10 meters per second squared. The first second is done for you. Okay, so the first thing we have to figure out is how long is it going to take for an object to fall off of a cliff that's 705.6 meters high? And I'm pretty sure I started it off and I wrote out here we go, the time equation right here. Since we had the delta y, then we can use this time equation. Now, if we had the delta x and velocity in the x, then we could have done that as well, but we only had the velocity in the x direction. Okay, so I did this before I started my video. So I took the t is equal to the square root of 2 times delta y over g. I filled in what I knew, and it was 2 times 705.6. 705.6 is the height of the cliff over 10. And then I ended up with the square root of 141.12. And then I had to do the square root of that. And your answer ends up being 11.8. I think it's 11.879. Yeah. 11.879 seconds. So that is the total amount of time. Now, as you can tell, this isn't a whole number, and that is the one thing you really need to keep in mind, that if you have this problem on your exam, don't go over. Like, if you stop at 11 and it's still not the enough delta y, then you need to go one more step, and that is to figure out exactly what the time is. So our time is 11.879, and so I just filled that in here. But let me go up here first. So to figure out delta x, right, well, we know that velocity in the x direction is constant. So that just means that for every second an object is moving, its horizontal displacement is going to change or increase at the same rate. Its displacement. Its velocity in the x will remain the same. It's going to be constant. So every second this object is traveling, its velocity in the x direction remains 16 meters per second. But its displacement, again, something different, is increasing by, well, whatever the velocity in the x direction is, which was 15 meters per second. So these go up in increments of 15. So second, it's 30 meters. That's where you are in the delta x. And it goes all the way until we get down here. And I'm going to solve these two here in a second. All right, and then our delta y. Delta y is figured out using this equation here. So it's delta y is equal to 1/2 gt squared. And just to like sum it up or to simplify it, it's really just -5 times t squared. So whatever your time is squared times -5. And that's how I was able to calculate the delta y. We have -20, -45, -80, so on and so forth, okay? So at 9 seconds, we're at -405. At 10 seconds, we're at -500. Sorry, I forgot the sign there. And then we're going to figure out what it is at 11 and 11.879 in just a second. All right, and then let's move on to our velocity in the y direction. So here we have velocity in the y direction, and it increases at a rate of -10 meters per second squared. So we know that from the equation. See, we have g, which is -10, and the time. So every time that passes, it's -10 meters per second more than it was the second before. So it goes in increments of negative 10 meters per second. So we have negative 10, then negative 20, negative 30, negative 40, negative 60, negative 70, on and on and on and on until we're here at 10 seconds. Okay, so we're here at 10 seconds and we have a delta x of 150. That means that the object has been displaced in the horizontal by 150 meters so far, and it's been displaced vertically 500 meters. And its velocity in the y direction is negative 100. And it doesn't say it here, but we know that the velocity in the x direction is 15 meters per second at this point as well, because remember, horizontal velocity is always constant. All right, so let's figure it out for 11. So 11 seconds, what is its delta x? Well, we're just going to increase it by 15 more meters, right? Or yeah, so it's 165 meters. Our delta y is increased by this equation here. So I took negative 5. Well, let me start at the top. 1/2 times negative 10 is negative 5. We have t squared. Our t is 11. 11 squared is 121. Negative 5 times negative 5 times 121 is negative 605. So at 11 seconds, our delta y, or our vertical displacement, is negative 605 meters. And our velocity in the y, well, it's just going to increase by negative 10 meters per second. So it's negative 110 meters per second. All right. Now, in our problem, it said that it's going to fall 705.6 meters. So at 11 seconds, it's not quite there. And at 12 seconds, well, it would be over. So we were able to calculate that our displacement would be, the time it would take to be displaced is 11.879. Now, to figure out what your delta x here is, we're just going to use, right, delta x is equal to velocity x times t. And we know that our velocity x is 15 meters, and we know our time is 11.879. So at this point, it's not going to be that nice little increment of 15. It's going to be a little bit shy of 15. So it's 15 times 11.879, and I get 178.19. Well, it's really 185. So that is my final delta x. Now, as far as my delta y, well, we know what it is because the answer was given to us. 705.6, and it is negative because it's going down. Now, what is our velocity in the y? Well, velocity in the y is just, remember, Vy is equal to g times t, and we have negative 10, and our time is 11.879. So if I multiply that by 10, I think it's like 118.79 meters per second. All right. So if you guys are faced with this sort of problem, it probably won't be you filling in every single spot along the line or every empty space in the data table, but I'll probably pick a few for you to calculate, and then you'll have to fill it in that way. All right, let's move on to the last problem. Oh wait, I think I skipped it. Let me go up. Sorry, guys. There it is. All right, so here is our last word problem. The super strong man from the circus is standing on top of the big top tent as he throws a watermelon into a small bowl of water situated on the ground below. The watermelon is launched with a horizontal velocity, so horizontal velocity, that will be our velocity in the x direction, of 20 meters per second and takes 7 seconds. We love it when time is there because it helps us to hit the water. How high up is the super strong man, and how far away is the bowl? So we know two things. We know that our horizontal velocity in the x direction, is 20 meters per second, and we have time of 7 seconds, which is awesome because, well, time is that golden value that you kind of want. And it's asking us to solve for delta y, how high up, and how far away, delta x. So delta y is equal to 1/2 g t squared. So remember, our first step was to fill in our list of knowns and unknowns. We know these three things here. I already started with the gravity. Second step is to write out your starting equation. And to solve for delta y, it's 1/2 gt squared. And then the third step is to plug and chug. Plug in what you know, and then chug out the answer. So we know it's 0.5, which is 1/2, times -10, times our time squared, which is 7 squared. 7 squared is 49. -10 and 0.5 ends up to be -5. And -5 times 49 is -245. And what was the value we were looking for? Meters. So that's how far up he is. Now, I didn't have to go through all that because if you can remember the chart, we know that 7 seconds, you're going to fall -245 meters.
Are you ready?
No.
What?
So -245 meters.
Mommy, can I do a video now? Can I do a video with you?
1 second, get out. 1 second.
Can I do a video?
No, get out. Get out.
Can I just
Get out.
do
1
a
more minute,
video?
please. Go. 1 more minute.
Can I just please do a video with you?
Oh, and 1 more minute. Get out, please. Close it. Okay, so the last part is to box your answer with the units. All right, now let's solve for delta x. Delta x is equal to velocity x times t. And we know velocity x, it's 20 meters per second. And our time is 7 seconds. So 20 times 7 is 140. And our delta x is 140 meters. There you go. It's not asking for velocity in the y, so we don't have to really worry about it, but that's pretty simple, right? If it's falling for 7 seconds, then velocity in the y is going to be 70 meters per second. Negative. All right, you guys, I hope that's helpful. Sorry about that little, interruption of my son, but he needs a lot of mommy time. Anyhow, let me know if you guys have any questions, please, and I can help you guys. Email me, and I will be in my classroom in the morning tomorrow before school starts. Hope this is helpful. Have a great day.